Okay, today we'll start another part, harmonic functions of a complex variable. Today we'll define the harmonic functions and solve some examples with solutions. So actually, first of all, what is harmonic function? So any function which satisfies the Laplace equation is known as a harmonic function. Actually, what is Laplace equation? First of all, you must know about this equation. These types of equation, del square u by del x square plus del square u by del y square. Actually, this is the equation of Laplace equation. Okay, del u square u by del x square plus del square u by del y square. Actually, it is two-dimensional, and if any function satisfies these types of equation, this is the u function for u variable, and this is for b variable. Same equation. It is called Laplace equation. So if any function satisfies the Laplace equation, it is called harmonic function. So for example, u equals to, this is the harmonic function, since del u del x, that means partial differentiation of u with respect to x will be actually ub process, making ub process, then u into b differentiation plus b into u differentiation. E to the power minus x differentiation, what will be? E to the power minus x, but coefficient of x what? -1 multiplied with the coefficient of x. So we get first partial differentiation of u with respect to x will be this, and second times differentiation, what will be? Second times differentiation, del square u by del x square will be this is the differentiation to the minus x, differentiation to the minus x multiplied with the coefficient of -1, but sin y will be constant for partial differentiation. So this is the ub, sin y will be constant, but this is the y function, this is y constant, and x e to the power minus x will be ub process, u into b differentiation plus b into u differentiation. So x into e to the power minus x differentiation, what? E to the power minus x into -1 plus b into b means what? E to the power minus x, and x differentiation what? 1. Then y into cos y will be constant for this partial differentiation. So e to the power minus x differentiation will be only minus x, e to the power minus x into -1. So we get, after adding and subtracting, we get this double differentiation. Now the differentiation of partial differentiation of u with respect to y, what will be? With respect to y, find out. Okay.
Yes, sir.
So the equation 2 will be the del square u by del y square equals to this. Now equation del square u by del x square equals to equation number 1, and this is the equation number 2. So just adding equation 1 and 2, we get what? This value will be what? Actually, just adding, we will get 0, right? And this is the actually, so Laplace equation is satisfied. So the given function,
Harmonic function.
okay, function
Is
e to the
harmonic
power
function.
minus x sin y minus y cos y is harmonic.
Harmonic function.
Okay. So this is the actually proof. Okay, now a theorem, if f of z equals to u plus ib is an analytic function, then u and b are both harmonic functions. You must know about analytic functions, that means a continuous at everywhere. Okay, so a differentiable at everywhere, we can say that that function will be analytic function. So we have to prove a theorem. Let f of z be u plus ib be an analytic function. Then we have from Cauchy-Riemann equations, del u del x equals to del v del y, equation number 1, and del u del y equals to minus del v del x. This is the condition of what? Cauchy-Riemann equations, remember it from analytic function, previous lecture. So differentiating equation 1 with respect to x, differentiating equation 1 with respect to x. Del square u by del x square equals to what will be? Del square b divided by del y del x. This will be what? Del u del x. Just differentiating equation 1 with respect to what? X. Similarly, differentiating 2 with respect to y. Differentiating 2 with respect to y. This will be what? Del square u by del y square equals to minus del square b by del y del x. Okay? Del y del x. So from these two, equation 3 and 4, adding equation 3 and 4 as the previous example, del square u by del x square plus del square u by del y square, what will be? This is the actually same. Okay? Del square b by del x del y and del square b divided by del y del x, same for continuous function and differentiable function. So this will be cancelled. We get 0. And this del square u by del x square plus del square u by del y square equal to what? 0. And existing this condition. So this is called what? Laplace equation. Remember it. And for similarly, we can prove another one for b function of xy, del square b by del x square plus del square b by del y square equals to also 0. So this is also Laplace equation for what? B function. And this is Laplace equation for u function. Therefore, both u and b are harmonic functions. Such functions u, b are called conjugate harmonic. These types of function, what will be? Conjugate harmonic, because u plus ib is also analytic function. So that the function u equals to half log x square plus y square is harmonic. Find its harmonic conjugate. We have to find out the harmonic conjugate also. So let us u equals to what will be? U equals to half log x square plus y square. This is given. So del u del x, what will be? Half into log x formula, what? 1 by x. 1 by x. Again, differentiation of x. X is what? Twice x plus 0. Y will be 0 because this is partial differentiation. Again, differentiation will be twice x. So we get only x divided by x square plus y square. This is the first partial differentiation of u with respect to x. Similarly, partial differentiation of u with respect to y, what will be? Just x will be y. Okay? Similar process.
Sir, আমরা কি স্যার সিমিলার লিখে দিলে হবে?
Of course.
একটা করে.
Okay. Del square u by del x square, double differentiation, what will be? Double differentiation of u divided by b. That means u by b method. You have to apply u by b rules of differentiation. Okay. So these rules will be what? In down b square, then in numerator b into differentiation of u. Differentiation of x, what? 1 minus u into u means what? X into differentiation of b. Differentiation of b means what? Differentiation of x square plus y square. X square differentiation twice x, y square differentiation what? Plus 0. Y square differentiation 0, because it will be with respect to x, and this is partial differentiation with respect to x. So you get only y square minus x square divided by x square plus y square whole square. Okay. Similarly, partial differentiation of second partial differentiation of y, again differentiation taking partial differentiation of u with respect to y on both sides of this u by b process, then you get only x square minus y square divided by x square plus y square whole square. Actually similar. Then adding, this is equation number 1 and this is equation number 2. So adding equation 1 and 2, similarly we can get what? Laplace equation. Okay. Del square u by del x square plus del square u by del y square equal to 0. So this is the Laplace equation. Remember it. Hence u is harmonic because Laplace equation satisfied. Now let us consider b be the another harmonic conjugate of u, because you must know complex function f of z can be represented by u plus ib. Okay. F of z equals to what was? U plus ib, and u and b are the function of xy. Okay. So b will be the must be harmonic of u. So db equals to what will be by according to the definition of total differentiation. This is the definition of total differentiation. db what will be? db by del x dx plus del b del y by dy. This is the definition from what? Total differentiation. By Cauchy-Riemann equations, you must know del b del x equals to what? Minus del u del y. And del b del y equals to what? Del u del x by Cauchy-Riemann equation. So Cauchy Riemann equation of previous lecture. So del u del y from the above function del u del y, what will be? Del u del y will be y divided by x square plus y square. Just putting these values. And del u del x is x divided by x square plus y square. So del dv equals to what was this? And this is the actually differential equation. Differential coefficient involved in this equation. This is why it is all differential equation. We have to solve by a method. So dv can be written as dv equals to this can be written as what? X dy minus y dx divided by x square plus y square. And this is the actual differentiation of what? Tan inverse y by x. Okay, differentiation of tan inverse y by x. So integrating on both sides, integrating on both sides, b equal to what will be? Tan inverse y by x plus c. And this is the actually b is the function of xy. So it is the complex conjugate of u. Okay, another example, prove 17, prove that u equals to this and b equals to this are harmonic function of xy, but are not harmonic conjugate. Okay, suppose we have u equals to x square minus y square and del u del x equals to what? Partial differentiation of u with respect to x, what will be? Twice x only. Y will be 0 because partial differentiation with respect to x. And double differentiation, what will be? Del square u by del x square, what will be? Only 2. X differentiation 1. Again, partial differentiation of y with of u with respect to y, what will be? Del u del y equals to minus twice y. Okay, minus twice y. So double differentiation, what will be? Del square u by del y square minus 2. Then this is easily, obviously, harmonic because it satisfies Laplace equation. Del square u by del x square plus del square u by del y square equals to what? 0. 2 minus 2 what? 0. U satisfies Laplace equation, hence u is a harmonic. Again, b equals to what? B equals to what? Y divided by x square plus y square given. So first differentiation will be similarly del b del x, what will be? This u by b process, u by b process. Partial differentiation of b with respect to x, u by b, and this, and double partial differentiation of b with respect to x will be again u by b process of differentiation. Then this will be the, so double differentiation, partial differentiation of b with respect to x square with respect to x will be del square b by del x square, what will be? U divided by b and b square, b into partial differentiation of u means with respect to x, minus u into partial differentiation of b. Okay, so we get finally del square b by del x square equals to 6x square y minus twice y cube divided by x square plus y square whole cube, because after taking common x square plus y square, here one will be cancelled, so this will be cube only. So again, taking partial differentiation of b with respect to y. Okay, similar process, we get x square minus y square divided by x square plus y square whole square, and del square b by del y square, second derivative, again u by b, u will be this and b will be this, so we get this one. So adding equation 1 and 2, we get del square b by del x square plus del square b by del y square equal to 0. So obviously the function b satisfies the Laplace equation. So b is also satisfies the Laplace equation, hence b is also harmonic function. But remember this, del u by del x is not equal to del b del y. That means Cauchy Riemann conditions are not satisfied. So u and b are not harmonic function. Sorry, analytic function. What will be? Prove that this u and b are harmonic, but conjugate are not harmonic, because Cauchy Riemann equations are not satisfied. So their conjugate u and b are not analytic and also harmonic. So similarly, the equation show that the function x square minus y square plus twice y is harmonic, remains harmonic under the transformation z equals to y w cube. Okay, So u equals to this given del u del x equals to twice x del u, and double differentiation will be only 2 del u del y, partial differentiation of u with respect to y will be this. Okay, so del again taking partial differentiation of y with respect to y, del square u by del y square equals to -2. So adding we get Laplace equation of u. So this is harmonic. Now making a transformation, z equals to w cube, that means z equals to what? R into e to the power I theta. You must know the polar representation of complex number. So r into e to the power I theta. So w equals to what will be? Capital R into e to the power I phi. We can consider phi as another parameter, and theta is also parameter, but phi another parameter. If we take w, so r e to the power I theta equals to r e to the power I phi whole cube, because omega cube, w cube. So r e to the power I theta equals to r cube and e to the power 3 I phi. So by comparing both sides, small r equals to r cube and e to the power I theta equals to e to the power thrice I phi. That means I theta equals to what? Thrice pi. So 3 times of phi. So given function x square minus y square plus twice y. This is the given. So if we put x equals to r cos theta and y equals to r sin theta, the polar coordinate of complex number. So x equal to r cos theta and y equals to r sin theta. In this, we get calculation r square cos twice theta plus twice r sin theta. So the polar form will be what? R cos thrice phi. Small r will be what? Capital R cube, and theta will become what? Thrice phi. Just putting here r cube cos thrice phi, r cube sin thrice pi equals to r square means what? This whole square, that means r to the power 6. So cos twice theta, and this is the twice r cube sin thrice theta. So this is a function in cosine and sine, hence it will be harmonic function. Understand everybody? Prove that u equals to x square minus y square minus twice xy minus twice x plus thrice y is harmonic. This is the actually equation of parabola or ellipse maybe, and this is the harmonic. Find a function b such that fz equals to u plus ib is analytic. Also express f of z in terms of z. So given function u equals to this, and first partial differentiation of u with respect to x will be twice x minus twice y minus 2 x differentiation 1 and y will be constant. This is y. So double differentiation of u with respect to x partially equals to what will be? Only 2. And again with respect to y will be this, and double differentiation will be this. So adding we get the actually Laplace equation. So this function is obviously a harmonic function. So u is harmonic. Again we know that complex conjugate is b. So by the definition of total differentiation, as before similar example, db equals to what will be? Del b del x dx plus del b del y dy. This is the definition of total differentiation. So db can be written as, now using Cauchy-Riemann conditions, del b del x equals to what? Minus del u del y, minus del u del y, and del b del y equals to what? Del u del x. Equation number 1. This is the equation number 1. Now putting the values of del u del y and del u del x in equation 1. Equation 1. Okay. Del u del x and del u del x. And del u del x means this, and del u del y equals to what? This one. Just putting here, we get a differential equation actually. So db equals to this. Now taking integration on both sides, db will be b equals to what will be? Integration of this with respect to x and integration of this with respect to y. So b equals to after integration we get twice xy plus x square. X integration what? X square by 2. So 2 cancel, only x square, and 3 minus 3 integration what will be? Minus thrice x. So this y square by 2 and 2 cancel, so minus y square and minus 2 into y. Okay, 1 integration y with respect to y. So plus c. So b equals to this. Now fz equals to what was? U plus ib, complex variable. So u equals to this and b equals to this. IC is the actually constant, complex constant, complex number. So separating this into x square minus y square plus 2i xy, and then just x square term, y square term, and xy term. Okay, so we can write x plus iy whole square, x plus y whole square, and x 2 plus thrice I and x plus iy. So x plus iy equals to what? Actually z, complex number. So z square, and this will be iz square, and minus 2 plus thrice I. It is also another complex number, and this is also z ic. Actually, this is the representation of f of z, complex variable, complex function. Okay, this is the result. Similarly, 22 will be homework for you. Similar concept used. So 21 and 22 is very important for you.